right, we're moving into 7.4, trigonometric values of special angles. I'm gonna clear this up a little bit. Okay, so we are starting off, this is a typo here, ignore this. But I just started off by giving you, recall that these are values from the unit circle for 30 degrees, 45 degrees, and 60 degrees. And then I wrote what they correspond to in radians. So this is pi over 6 radians, pi over 4 radians, and pi over 3 radians. And here are sine, cosine, and tangent for all of those. So you can kind of use this as a reference throughout this next unit, or this next section, I should say. And then we talked about reference angles. So for an angle, theta, in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So we haven't explicitly talked about this yet. I've kind of alluded to it, I think, but let's just look at if we've got an angle, or an angle theta. I'll put a point here. We've got this angle theta in the first quadrant. Then our reference angle is also this angle right here. It's always acute, okay? But this changes as I move around the unit circle. Okay, so now let's say we're in quadrant 2. This is my standard angle, but the acute angle that it makes as the reference angle is this little angle right here. It always comes back to the x-axis. So that's how I usually draw our little triangle, you know, when I talk about sine and cosine, I'm using this inside angle, even though this is the standard angle of theta. Okay, but you use the little angle that it makes with the x-axis to use the reference angle. Okay, next one, if we're in the third quadrant, all right, the whole angle around here is my theta, technically, but my reference angle is just this little angle that it makes right here. This little shaded angle back to the x-axis. And lastly, if we're in the fourth quadrant, right, we go back like this. This is our reference angle, even though this is our standard angle. Okay, so that's just a distinction between reference angle and standard position. So we're going to be using the reference angles, these little angles inside that are always an acute angle. And we're going to call this, in this one, we call this x prime down here. So it says to find trigonometric function values. First, we need to find, we need to sketch an angle of x in radians in standard position. So that's where we can potentially go all the way around the circle, standard position, and then determine what quadrant it lies in. So 1, 2, 3, or 4. Then find the reference angle. So what's the little angle that we're talking about that has the measure of x prime? We're going to call that the reference angle, x prime. Reference angle, and it should always be acute. Okay, and then to find sine, cosine, and tangent of that reference angle, we're going to use the appropriate signs. So that kind of goes back to what quadrant we're in. That's why we can use the reference angle. It's going to probably be one of these, but then we use the proper signs depending on the quadrant. So remember that if we're in quadrant 1, x is positive, y is positive. So that means sine and cosine are positive, and also tangent. I should color code this with my colors up here. This is the first quadrant, so all blue. All right, next I use that pink. We're in the second quadrant. So in the second quadrant, x is negative, y is positive. So that means sine is positive and cosine is negative, which means that tangent's negative. Then in the third quadrant, x and y are negative, so sine and cosine are negative, which means our tangent is positive, negative divided by negative. And last but not least, we have a positive x value in the fourth quadrant, a negative y value. So that means sine is negative, cosine is positive, and our tangent is negative. Okay, so last little thing, just a little reminder, sine of theta is the same thing as y. Cosine of theta is the same thing as x. And tangent of theta is sine over cosine, which is y over x. Little extra note there for all of you. And that's going to do it for definition. So we're going to use this definition page throughout the next problems.